Hello students, I welcome you all on my YouTube channel. In this video we will be taking some more problems on group so that you could get a clear idea of group, right? So without any delay, let's study problem number 1. Let Q star denotes the set of let Q star denotes the set of all rational numbers except 1, right? 1 is not part of this set. Then show that Q star forms an infinite abelian group. Okay, under the operation star defined by a star b is equal to a plus b minus ab for all a comma b belonging to Q star. So solution here. So see what sort of set we are given here. Q star where star does 1 does not belong to Q. Okay, all those rational number except 1 is not part of the set, right? So solution. Okay, in solution you are going to write it again, that let Q star be the set of all rational numbers except 1 and operation star is defined as a star b is equal to a plus b minus ab. Fine, we have to show that Q star under operation star, or you can change the operation here because you will be encountering with 2 stars, so you can change this with O, right? Or you can carry on with star also. There is no big mistake, or there is no major difference. So we would we shall show that Q star O forms an infinite abelian group, right? Why I'm changing this sign to O, because here is also star, here is also star, right? So you will be getting confused between these two star. You will be getting you will be thinking that okay, these two stars are same, this is also operation, but these are quite different. This star is operation and this is distinction from the, and second star is distinction from the this rational number, so that you can keep in your mind that 1 is not the part of this set, right? Okay, fine, I'm carrying with a star only. I'm carrying forward with star operation. Okay, so first, if we want to prove that this is a abelian group, we will have to show all 5 properties: closure property, associative property, existence of identity, existence of inverse, and at last commutative property, right? So let's start with property number 1, closure property. Okay, in closure property we show that if if we are having 2 elements from Q star, then we will have to show that A star B is also element of Q star. Thus we will be able to show that this set Q star is closed under operation star, right? Okay, you see what is problem with A star B is equal to, operation given is this. Obviously we know sum of 2 rational number or plus minus of 3 rational number is again rational number, but problem is we are having not only rational number, but one has been excluded from this rational number, right? So the set is Q star, and we shall show that Q A star B belongs to Q star. We want to show this. In order to show this, we will have to prove that, okay, we know this, that this is equal to rational number, but if we want to show that this belongs to this, we will have to show that this is not equal to, A star B is not equal to 1. Okay, this we are going to show in this case, because already we know addition and subtraction of any 3 rational number is again rational number, but it must not be equal to 1. Therefore this is the only thing we will be thinking. So see, what if A star B is equal to 1, then what would happen? A plus B, since we know A star B is equal to A plus B minus AB is equal to 1. Okay, taking it to the right hand side, left hand side, A plus B minus AB minus 1 equal to 0. Now see these two terms, I'm clubbing them and taking out A. Now I'm clubbing this and taking out minus 1. So I'll be left with 1 minus B equal to 0. Now taking out minus B, 1 minus B, and inside we will be having A minus 1 equal to 0. So see, if a product of two number is 0, okay, product of two number is 0, then either this or this must be 0, right? So therefore either 1 minus B is equal to 0 or A minus 1 is equal to 0. If 1 minus B is equal to 0, this implies B is equal to 1 or A is equal to 1. But this is contradiction, because these two, neither of them can be equal to 1. Why? Because A comma B are elements of Q star, and Q star contains all those elements which are not equal to 1, right? So therefore it is contradiction. Hence we can say A star B could not be equal to 1. It is never equal to 1. So therefore A star B is some rational which is not equal to 1. Hence we can say A star B belongs to Q star. Okay. So we will have to write this explanation in this under this property, closure property. Okay, let me drag it here. Now next property, closure property, associative property, property 2, associative property. In this property we are going to show that A star B star C is equal to A star B star C. Okay, let us check one by one, are they equal or not. Okay, let us simplify them one by one. Okay, firstly you see this has been put in the bracket, therefore we are going to solve what is in the bracket first, because we know operation is plus, operation A star B is equal to A plus B minus AB. So therefore it would be B plus C minus BC. Further, this is one element now. Okay, consider this like it is one element alpha. Then okay, it would be A star alpha, it is equal to A plus alpha minus A alpha. You see A plus alpha is equal to B plus C minus BC minus A time B plus C minus BC. Okay, so one more time, simplification, A plus B plus C minus BC minus AB minus CA plus ABC, right? Now take another part, A star B star C is equal to what? So operating this first, we get A plus C minus AB star C, which is equal to, now consider this one element, for example beta, it is equal to beta star C, beta plus C minus beta C, and beta is equal to A plus B minus AB plus C minus beta into C would be A plus B minus AB into C, right? So it is equal to A plus B plus C. Now you see minus AB minus AC, or you write it CA, okay, minus BC plus ABC, right? So you see these two are equal, hence we can say therefore A star B star C is equal to A star B star C. Okay, thus associative law is true in this case. Therefore this set Q star holds associative property. Okay, now property number 3 is existence of identity. Okay, if identity exists, then for identity we must have A star E is equal to E. Okay, this is identity. Let us check what comes identity in this case. We know A plus E is equal to operation when A star is equal to A plus E minus A time E is equal to E. Okay, so it is equal to A. Okay, it is equal to A cancel. Now this implies E minus AE is equal to 0. This implies take E outside of this, so we must be having this. Now you see product of two number is 0, either this should be 0 or this should be 0. Okay, either E is equal to 0 or 1 minus A is equal to 0, but this cannot be equal to 0, because if this is equal to 0 then A is equal to 1, but A belongs to Q star and Q star does not contain 1, right? Hence therefore E is equal to 0, which serve as the identity for Q star under given operation. Okay, now fourth property, existence of inverse. Existence of inverse. For inverse we must have, if we want to find out inverse of A, we must find out some another B such that product is equal to E, right? So A star B is equal to A plus B minus AB is equal to E, and E is equal to 0. So therefore take A to the another side, so we are left with B is equal to minus A, B common, 1 minus A is equal to minus A, so B is equal to minus A over 1 minus A. Okay, so now cancelling this sign, B is equal to A over A minus 1. Therefore inverse of A is equal to, or also we can write thus, A inverse is equal to A by. Okay, so this will acts as inverse of the A, right? Or you can check it, check this thing also, that is it inverse of A or not. If we operate A with A by A minus 1, what is result, right? So let us check it out. A plus A by A minus 1 minus A into this, it would be A square minus, okay, fine, it is equal to this, and this is equal to, let us take LCM, A minus 1. Now you see A time A minus 1 plus A minus A square, solving it out we will be having A square minus A plus A minus A square by this. So cancel and we are, it is equal to 0. So it is equal to 0, which is identity in this set, or right now it is set, but later on we will see that this is group, right? So it is equal to E. Therefore we can say this element is the inverse of this. So in this way we can find out inverse of any element. For example, give me some number 2. What is inverse of 2 in this case? In this case, inverse of 2 would be 2 by 2 minus 1, which is equal to 2 again. That is, 2 is the inverse of itself, right? If you give me 3, then inverse of 3 would be 3 by 3 minus 1, which is equal to 3 by 2, right? That is, if we operate 3 and 3 by 2, it gives 0, right? So let us check this out. 3 plus 3 by 2 minus 3 into 9 by 2. Okay, so you see this is equal to combinedly 4.5, and this is also 4.5, so it is equal to 0, right? So thus we can find out inverse of any element. Thus we at last we can write, here a was taken arbitrarily, here a was taken arbitrarily, therefore arbitrarily, okay, therefore inverse of each element exists, right? Now one last property, commutative property. So see, a star b is equal to a plus b minus ba, and b star a would be equal to b plus a minus ba. Since we know product of two rational number is commutes with each other, so it could be written a plus, okay, write this, it could be written, I'm sorry, here we want to take a and b, okay, it is b and this is a, okay, right, this is a. So now a plus b is equal to b plus a, and a into b can be written b into e, because product and sum in case of rational number commute, right? So it was also this, so hence we can say a star b is equal to b star a for all a comma b belonging to q star. Thus all four properties are held by this set. Thus q star forms group, not only group but abelian group, okay, abelian group under given operation, okay, it is infinite abelian group, infinite abelian group, because number of element in q a star is infinite, it contain infinite element, therefore it is known as we call it infinite group, okay, infinite, because if it had been the case that this set contain finite number, then we would have called it finite abelian group, right? So this is it.